Alright, ladies and gentlemen, this is going to be a quick video here, my friends. We are talking today about scientific notation. We need to be able to express numbers in scientific notation, but we're also going to extend it a little bit more from last year to be able to find products and quotient of numbers in scientific notation. So first, let's refresh. What is scientific notation? So basically, when we have really big numbers or really small numbers, we use exponents to express the number of place values that that number has. So keep in mind that scientific notation has a lot to do with place value. Okay? And the way that we write that place value is using the number 10 to an exponent. The base has to be the number 10 in order for us to be speaking about scientific notation or place value. And so, real quick here, 10 to the third is 1,000, 10 to the fourth is 10,000, 10 to the fifth is 100,000. So going the other direction, if 10 to the third is 1,000, 10 to the negative third is 1,000th, th there at the end. So if we're talking about 10 squared, which is 100, then 10 to the negative 2 is 1/100th. Okay? So what we're looking at here are the more negatives, the more place value. So negative 4 is 1, 2, 3, 4 places. Negative 3 is 1, 2, 3 places. Positive 4 is 4 places. Positive 5 is 5 places. Okay? Positive numbers make big numbers, positive exponents. Negative exponents make small numbers. So let's do some recap here. If I want to write 3.16, 3 and 16th hundredths times 10 to the negative 2 in standard notation, that means with all the zeros. Okay, what I notice is I have a negative exponent, so that means that I'm going to make a small number. So my decimal goes 2 places to the left. So that is 0 point. That's where my decimal's going, right where that E is, right there. Okay, so I've got 0.0316. Okay, there's the decimal, right where that E is. Alright, so that's standard form. How about this one? 7 and 61/100ths times 10 to the third. So it's to a positive exponent, so I'm going to move my decimal to the right, making it a big number. 3 spaces. Okay, so that would be 7, 6, 1, 0. And then I just need to fill in my commas. Remember, a comma goes every 3 spaces. So this is 7,610. Alright, how about going in the opposite direction? How do you write a number that is in standard into scientific notation? Well, the first thing we have to do is we have to remember this little trick here. A times 10 to the nth. That's the basic format of any number in scientific notation. And that value, A, has to be less than 10 and greater than or equal to 1. Basically, you have to have only one digit to the left of the decimal. So where am I going to put my decimal in this number in letter C? 458 million. So I want to put my decimal between the 4 and the 5. Why? Well, because now I have the number 4.58. And that's 4.58 times 10 to what power? Well, the decimal was originally at the end here. and I moved it 1, 2, 3, 4, 5, 6, 7, 8 places. So that's to the 8th power. So now I've written in an exponent and in scientific notation. All right, let's look at letter D. Letter D shows us a really small number, so that means I'm going to use a negative exponent. Again, I want to move my decimal to a spot where my number becomes something point whatever. Only one number to the left of the decimal. So I want to put my decimal between the 4 and the 5. So that would give me 4.52 times 10 to the negative, because I'm representing a really small number, 1, 2, 3, 4, 5. Because I moved my decimal 5 places. Alright, so I hope that was enough to kind of give you a refresher of how we do scientific notation. If you need more help, come on into office hours. Alright, so extending this concept, we want to apply the exponent rules that we've learned in the past 2 videos to scientific notation. So what I have here is 5 times 10 to the negative 6, which is scientific notation, times 2.3 times 10 to the 12. And so I want to multiply that as easily as possible. I could convert each of these into standard notation and then do the multiplication, but that's really going to take a lot of time. Instead, what I want you to notice is this is all multiplication. So I can put it in any order I want. And notice now, I can just multiply these numbers like normal. And the tens have the same base. So what can I do with those exponents? I add them. 5 times 2.3 is 11.5 times 10. Negative 6 plus 12 is 6. Now we only have a small problem here. The problem is our A has to be between 1 and 10. So I need to move that decimal 1 place to the left, making it smaller. So to balance it, I need to make the exponent 1 place bigger. So my final answer is 1.15 times 10 to the 7th. Again, I made my number 11.5 smaller, so I make the exponent bigger. I need to keep it balanced. If I take it away from here, I have to add it to here. Let's try another example. Notice in this one I've got division. Again, I could change both of these into standard notation and then divide them and then convert them back into scientific, but that's going to take a lot of work. Instead, notice that these are normal numbers. I can just divide them. 4.5 divided by 1.5 is 3. And then all I have to do is, since these are the same base, I need to subtract their exponents. So 8 minus 10 is negative 2. And because we're dealing with scientific notation, negative exponents are okay. So we've got our 2 final answers there. Let me show you an example if I were to have a number for A that was too small and I had to make it bigger. So for example, let's say I've got 0.3 times 10 to the 5th. Okay? How would I make that scientific notation? Because this is not truly scientific notation because it's not between 1 and 10. So I would move my decimal 1 place to the right, making the number bigger. So I would need to take 1 away from the exponent. That would make this 3 times 10 to the 4th. True scientific notation. Alright, so I'd like you to try some homework. Page 417, numbers 1 through 18 odd. Okay, cross out those even ones. Only doing the odd ones. Make sure you show all your work.